In these questions, we're now using our differential rate law equation to figure out the rate constant K for a given reaction. So in this question, we have a reaction between fictional substances Q3L and AM. So you can see we've got 2 Q3L and 3 AM reacting together. And the scientist experimentally determines the differential rate law. Rate equals K multiplied by the concentration of Q3L cubed multiplied by the concentration of AM squared. So we can see we've got third order with respect to Q3L and second order with respect to AM. We're also given the initial concentrations of each reactant and the initial reactant rate for a given trial in this table here. So if we have a look at what we've got, in our equation here, we've got rate, which we have here. We've got K, that's what we're trying to find. We've got the concentration of Q3L here. And we've got the concentration of AM here. So we have all our variables apart from K. So we're going to be using that rate equation. We're going to be rearranging it for K and using that to calculate the rate. So let's go ahead and do that now. So we've got rate equals K multiplied by Q3L cubed multiplied by AM squared. Those are the concentrations. That's what we got given in the question. We want to rearrange for K. So I'm going to divide by the concentration of Q3L cubed multiplied by the concentration of AM squared on both sides. So that's going to cancel out on the right-hand side, leaving me with K equals rate divided by the concentration of Q3L cubed multiplied by the concentration of AM squared. Okay, so there's our equation for K. Let's put in our numbers to figure out what K is going to be. So our initial reaction rate was 0.0700 from our table. The concentration of Q3L initially was 2.40, and that's cubed. And the concentration of AM initially was 2.80, and that's squared. So putting that all into our calculator, we get out a value for K of 0.000646. So let's go ahead and fill that in to see if we got that right. 0.000646. Awesome. So just as a reminder to do that, we took our rate equation given in the question, we rearranged for K, and then we just plugged in the numbers that we were given. Now we still need to add our unit, and K is interesting because it has different units depending on the form of our differential rate law, depending on what orders of reaction we have. So to figure that out, we're going to have to think about the units of everything inside our calculation for K. So I'm going to make some space here. So to find our units of K, we're going to put our units in for each of our things in our equation. So rate has units of molar per second. Then we're dividing that by the concentration of Q3L, which has units of molar, and that's cubed, multiplied by the concentration of AM, also has units of molar, and that's squared. So if we write this out a bit more clearly, we've got molar divided by seconds, and on the bottom of our fraction, we also have molar cubed and molar squared. So my molar on the top is going to cancel out with one of my molars on the bottom, and I'm left with 1 divided by seconds times molar to the power of 4. So that's my unit. It's going to be per second molar to the 4. So So let's see if that's an option. We've got per molar to the 4 seconds. So you actually have to figure out your units each time based on the equation. And you can just do that by putting in your units for each thing and cancelling them out to see what you end up with. Let's do one more question of this type. In this question, we have a reaction between fictional substances Z6X4 and T2. So we can see on our equation, we've got 1 Z6X4 reacting with 7 T2. And again, we're given the differential rate law. It's K, concentration of Z6X4 to the power of 3. And we're also given K, the rate constant, is 0.00583 per molar squared second. And our goal this time is going to be figuring out the initial reaction rate based on the initial concentrations of each reactant given in the table. So let's go ahead and write out our rate equation down here. So we're trying to find rate. K we know because we were given it in the question. The concentration of Z6X4 is also given here. And those are the only things in our equation for rate. Notice that T2 isn't included in the equation for rate. That must mean that it's 0th order. So we've been given the initial concentration of T2, but that doesn't actually have any effect on our rate. So we don't really need that information in this question. So to calculate our rate, all we need to do is go ahead and put in our numbers. So for K, given in the question as 0.00583, multiplied by the concentration of Z6X4, which is 3.80, and that's cubed. So if we put that into our calculator, that's going to get us a rate of 0.320 molar per second. Let's check that answer here. Awesome. So this one's really simple. To find the rate, we just plug in our numbers for the rate constant and any initial concentrations that we've been given to figure out what the rate's going to be.